These are notes on reaction types. Reactions can be categorized into different types based on how the reactants interact to form products. We've already talked about some of these. For example, we talked about combustion, where a reactant would react in the presence of oxygen and burn. It's called combustion. We're going to talk about we're going to categorize reactions into 4 main types. There's certainly others as well, but we're going to stick to these 4. I would say that they're the 4 most basic. The first type is called a synthesis reaction. A synthesis reaction is one in which 2 reactants bond together to form one product. So generally we can write that as A plus B yields a product of AB. An example of that would be iron plus oxygen gas yields iron 3 oxide, which is the reaction we saw when we burned the steel wool, which coincidentally is also a combustion reaction. And you'll notice this equation isn't balanced. We could go through and balance it. I don't know that we need to, although we certainly can. We can, put in, let's see, we would need 3 of these and 2 iron 3 oxides, and then, 4? Yeah, so that's now balanced, but it's still a synthesis reaction. We're still saying that A, which would be the Fe, the iron, plus B, which would be the oxygen gas, yields one product, which is iron 3 oxide. And so the opposite of a synthesis reaction is a decomposition reaction. And that's one in which you have one reactant and that decomposes into 2 products. So a decomposition reaction is one in which one reactant decomposes to form 2 products. I think I already said that, but then my children walked in from the wading pool outside, so I got a little sidetracked. Anyway, it's like AB, so that's one compound, decomposes to form A and B. And where you see this, for example, if you run an electric current through water, it's called the electrolysis of water. And you get water, which then decomposes into or breaks up into hydrogen gas plus oxygen gas. And again, this isn't balanced. We could certainly go through and balance it. I'm not going to at this moment. But you see that the AB is the H2O, and that yields an A, which is hydrogen gas, plus a B, which is the oxygen gas. The third type of chemical reaction is a single displacement reaction. And in some places that you look, you're going to see this as a single replacement reaction. I learned it as displacement. You're going to see it as displacement a lot. Doesn't really matter if you say replacement or displacement. And a single displacement reaction is one that is generally written as A plus BC, so an element plus a compound, where then A replaces or displaces the B, and you get AC plus B. An example of that would be magnesium plus water yields magnesium hydroxide plus hydrogen gas. So the magnesium has come in and replaced one of the H's, and you end up then with that H being replaced, and you get H2, that's the hydrogen gas, and then you get magnesium hydroxide. Again, not balanced, but it serves the purpose of the equation. So then the last type of reaction is called a double displacement reaction, or again, sometimes you'll see this as a double replacement reaction. And this is one in which you have AB, so a compound AB plus compound CD, and then the A and C essentially replace each other. So you would have AB plus CD yields AD, and this should actually be, sorry, this is a little bit of a mistake. This should be AD plus CB. There we go. And so the A and C have essentially switched. The C is now bonded to the B, the A is now bonded to the D, and there are lots of rules that we're not going to worry about as far as when this happens and why this happens, both with single and double displacement reactions. But an example is, for example, lead nitrate. The lead is the A, the nitrate is the B, plus potassium iodide. The potassium is the C, the iodine is the D. And then those swap, and you get the lead and the potassium swapping. So you get lead iodide, so that would be the A and the D, and then potassium nitrate. The potassium, again, is the B, and that's now, the potassium was the C, and that's now bonded to the B, which is the nitrate. So hopefully those four make sense. Your homework then is to look at your balancing equation sheet, and with those, I think there's 8 reactions in addition to balancing them and then naming whatever thing is underlined. I want you to write in which type of reaction each of them is based on these 4. And that's due completely on Friday.